Okay, so as I said at the end of the last video of section 2, is section 3 is going to look at other normal distributions, and we want to decide if we can take those normal distributions and do the same things that we did in section 2 on a standard normal distribution. Well, it turns out you can, okay, by converting those values given in that non-standard to standard normal distribution. And we did that already. When we were back in chapter 2, I think it was, doing the statistics, we talked about how to change an x-score to a z-score. Okay, so here's what we're literally trying to do with these. Okay, we know that our non-standard distribution has a mean, a standard deviation, okay, that's unique. And then in there, we have specific values we're trying to find, x values. Okay, well, what we're trying to do is we're trying to force this to look like this. Here is our mean at 0. Our standard deviation is 1. And then what would that change our x value? Our x value now becomes some z value, a z-score. Okay, so because when I can take this information and change it to this scale, then those tables that we were using in the previous section now become available, and all of those probabilities and areas under the curve are now accurate. Okay, so what we want to do is we're going to take a non-standard distribution, we're going to change it and match it up and convert it to a standard normal distribution, and then we're going to look at, again, just like we did, what's the probability of something being less than, greater than, or between two known values. Okay, and in some cases, again, even going backwards, if I give you the probability, then what actual value did that come from? Okay, so here's another formula that you should be aware of. You might want to jot it down up there. Okay, so to go backwards and find the actual x score, we said that was mu. I have to check here. So z equals x minus mu over standard deviation. So there it is. Okay, so to change it back to an x score, you take the mean plus the z score times the standard deviation. Okay, so changing it to a z score, I need this one. Changing it backwards to an x score, I need this one. Okay, keep those in mind. I'll be playing with those in some of the different problems. Okay, now I gave you a lot of different notes and stuff with this for different things that they talked about here, but in terms of the actual the actual questions, probably, you might take some time to read through this last little part here. Okay, there's some important things there just to keep in mind, but the rest of it, not so much. Won't play a role in terms, you'll see that when we start working problems. Okay, so taking a look there. Okay, keep that in mind. Okay, so on the exercises, you can see they start off with some graphs just like we did before. Okay, so number 2, find the probability that if x is greater than 80, okay, then what Z value, what probability do we get out of that? This came from an adult IQ test where the mean is 100 and a standard deviation is 15. So I can see that 80 is less than 100. So the probability that X is less than, or excuse me, this is a greater than problem. Okay, the shading's a little bit easier to see on this, but here's my shading. Okay, what's the probability of getting someone that has a score greater than 80? Well, so Z equals 80 minus 100 divided by 15. So that would be negative 20 divided by 15, which is, and you need to make sure you're going to round these for the table's sake. You're going to round these to 2 decimal places. That's negative 1.33. That's my z-score. That's my corresponding z-score to 80. So I want to find what's the probability that z is greater than negative 1.33. So now I'm going to go to my table. First, got to find my table. Okay, negative 1.33 is 0.0934. So because it's a greater than, this is going to equal 1 minus point. I'm going to take that back. It's going to be 33 would be 0.0918. Okay. So again, we're subtracting from 1. So 1 minus 0.0918. I get 0.9082. Okay. Now the between problems just become a little bit harder too, because you have to convert 2 different numbers before you go into the between process. Okay. So this one here, number 4. Okay. So I know I'm going to take the probability that X is less than 110 minus the probability that X is less than 75. Okay, that's how you do a between problem. Okay. And the problem is I don't want X's, I want Z's. So if Z equals 110 minus 100 over 15, I get a z-score of 0.67. When I take 75, minus 100 divided by 15, I get negative 1.67. So I'm taking the probability that z is less than 0.67 minus the probability that z is less than negative 1.67. So now I can go to the table and look those up. .67 7486. Negative 1.67. 0475. Okay, subtracting those. .7011. Okay, so the processes are the same from what we did in section 2. The only difference is we need to use that z-score formula, okay, to calculate convert it first. Sorry, convert that thing first. Okay, now on 5, 6, 7, and 8, again, they give you a probability this time, an area under the curve. Okay, we need to change that back to, okay, an actual x value, not a z-score, an actual x value. So this is where that other formula will also come to play. Okay, so here's what I'm going to do first. Looking at number 6, it is a greater than problem. Okay, so let me get it up where you guys can see it. Okay. So if I know that 0.8 is the probability under the curve here, I can go ahead and subtract that right off the bat. Then I know that 0.2 is my value to the left, okay, to the left of the line. Okay, so I'm going to use the probability 0.200, 3 zeros, okay, and I'm going to look that up. Remember, I'm left of the mean, so that means that it's got to be negative, okay, and so I'm looking in the body of this actual graph here, of this table, and 0.2, there is no exact value for 0.2, okay, but I want you to notice that there, we want to narrow it down. Which two is it between? Okay, so 0.2 is going to be between this 0.2005 and this 0.1977, and it's closer to, it's only 5 away from this one, so I want to use negative 0.84 as my z-score. Okay, so find the one closest to it if you can't find an exact value. Okay, now from there, now I can plug into that. Now that I have a z-score, I can use that other formula. Okay, so x equals mu. We're still doing with those IQs, so that will still be 100. Okay, plus the z-score times the standard deviation. Okay, so taking your calculator now, negative 0.84 times 15 added to 100, I get an X score of 87.4. Okay, so that's how you want to approach those problems. Okay. In the next group of problems, they start to ask you to do some of the same things without a picture. 9 through 16. And then let's look at number 12. Try to pick out just a couple here. Okay, number 12 says, find the probability that a randomly selected adult has an IQ between 110 and 120. Okay, so again, I have 110, 120. It's a between problem, so I'm going to subtract, okay, the probabilities. But first I need to convert those X scores, those raw X scores, to Z scores. So X is less than, converting 110 minus 100 over 15, 120 minus 100 over 15. This again is 0.67. This is 1.33. Okay, so again, just like we did previous, it's a between problem. The probability that Z is less than 1.33 minus the probability that Z is less than 0.67 will be the probability between those two events. So now I'm going to look those up. On the wrong side. Point 9082. 0.7486. Okay, 0.1596. So there's almost a 16% chance of randomly selecting someone that falls between that IQ group. Okay, so that's what this is doing for us. It's giving us a means, again, to look at probabilities for these different kinds of events. As long as they are normal, then we can use standard normal with these procedures and with these Z-scores to find those probabilities. But again, it's either less than, it's greater than, or it's between. Okay. Number 15. Okay, find the third quartile, Q3, in which the IQ score separates the top 25% from the bottom. The top from the bottom. Okay, so that means that on my normal curve, again, I'm trying to find the X value. But that X value has a probability of 0.25, 0.2500 here. That's 25% in the top. So it has to have 75% in the bottom. So looking up the 0.75 on the bottom, that's going to be 0.52. Okay. 75% above here just double checking my numbers here. Okay, it has to be 0.52 on your z-scale. Okay. Now we can, again, since we're trying to find the raw score, then 100 plus 0.52 times 15. Okay, so I get 107.8. Okay. So again, keep in mind they're going to ask you, if they're asking you for a score, you're going backwards. If they're asking for a probability, then you're going to plug in and move it forwards. Take the X, change the Z, okay, perform the procedure. Otherwise, take the probability, go back to Z, and then back to X. Okay. On these exercises, I may have got a little carried away with the problems here. I'll let you stop at number 20. Okay. So that's going to be plenty of practice with these. Okay. So 17 through 20 here. This time they're using standard normal, a normal distribution involving men's and women's heights. Okay. And what we want to do there is, again, be prepared to go backwards. Are you given percentages or are you trying to find percentages? Okay, I guess that's kind of key. Okay. Number 19 says, Tall Clubs International is a social organization for tall people. It has a requirement that men must be at least 74 inches tall. Women must be at least 70 inches tall. Okay, so what percent of men and women meet those requirements? Well, again, let's take it and change those to z-scores, and then we can look them up. Okay, so on starting out with men, okay, I know that X equals 74. Okay, and on the previous page in the directions, let me find it here. Okay, so for men, the mean is 69.0. Standard deviation is 2.8. Okay, for women, this is going to be for part B. The mean is 63.6. Standard deviation is 2.5. Okay, so so Z equals 74 minus 69 divided by 2.8. So 75 minus 69 divided by 2.8. I get a z-score of 2.14. Okay. So I know that people that fit have to be bigger than that. Okay. So when I look up 2.14 on the positive side, I get 0.9838. Okay, yeah, so 9838 is the probability of being less than that. So if you're a tall person, you've got to be greater than that. So the probability of Z greater than 2.14 is 1 minus 0.9838, which is 0.0162. Okay, so only about 1.5% of the population, okay, fits that category. Okay, which would make sense there. If it's going to be an exclusive club, it should have exclusive parameters. So, the number of women, percent of women that meet it. So I'm going to use an X of 70. So we're going to do the same thing. Find the Z-score. 70 minus 69, or excuse me, 63.6 divided by 2.5 this time. Okay, let's see what Z-score we get out of this. So I get 2.56, okay, which is even greater Z-score than for the men. So when I look it up, I get 0.9948. Look at that again. Yeah. So subtracting it, I get 0.0052. So only about 0.5% of the population, okay, fits that category. So, with the exception of the conversions, okay, using z-scores, finding z-scores, converting back and forth, it's very similar to what we've been looking at. So read the questions carefully. If you need a little bit more of an interpretation of what they're asking you to do, or need to see something else down the line, just send me an email and I'll get stuff back to you. Okay. But I'm hoping we've got 2 sections. We're skipping section 4. Okay. 2 sections that are going to talk about some variations on this and how we talk about those. And one of them, the next one's kind of important, the central limit theorem. But we'll talk about those and wrap up from there. Thanks.